So the equation at the board, you have the rate of the equation of the reaction, and they already give you the rate of the decomposition of N2O5. Now they want you to know what is the rate of the appearance of this. From the equation, you can see that this is disappearing and these two are what? Appearing. I don't want to waste much time. If you have been following my videos on this channel, you can get all of these my videos on this chemical kinetics. This is almost the part 4 of this video. This is the way we write the rate of the reaction. I don't want to waste much time on this video. So, having written the overall rate of reaction, you can see what we will do is they are giving you that of this. So you have N2O5 to be 4.2 times 10 to the power of minus 7, right? Now they want you to get NO2. Now all you have to do is you equate this to this and you get your answer immediately. Remember in those videos, if you were in examination, you already know that of this to be this. So all you need to do is you carry this thing immediately to this place, bam, and you times it, you get your answer. We know how we used to do it. Let me solve it. So this is minus 1 all over 2. Of course, you have dN2O5 all over the T. Now I want to get out of the O2. I will equate to this. Remember, the rate of disappearance is equal to the rate of appearance. So this is 1 all over 4 dNO2 all over dt. Now, remember I said something in the part 3 of this video. I said that always note, be careful whenever we are talking about when something is appearing, when something is disappearing, be very, very careful. We said it. Now, from this formula we have minus, but remember this is here, it is disappearing. So I'm going to have to include minus here. Why? Because it's disappearing. We said whenever something is disappearing, you have to include minus to show that it's disappearing. If it is appearing, it means that it's on the product side. You have to include a plus sign to show that it is increasing. So from here, all I need to do right now, the short method, of course, is remember there is a minus here, right? So what I want to do, I want to make this the subject of the formula. I want to make this subject of the, I want to make this one subject of the formula because they ask us to calculate this. We already have this, right? So all I need to do right now is keep this, bring this, put it here, times it and invert it. That's how we used to do it. So this will give me, so d N2 all over the t will be equals to minus 1 all over 2 N2O5, right, times this coefficient, I will invert it, times 4 all over 1. That's all. Now, you already have this. They gave you this value. And remember, there is minus in it. So, the answer to this right now will be, let me write it here. This one, I don't want to waste time writing this thing again. So, the N2 all over the T is, this is it, minus 1 over 2 times, open bracket, minus 4.2 times 10 to the power of 7, right? Times this 4, right? Look at it here. I just inserted the value. You punch it in your calculator. What you should get as your answer should be 8.4 times 10 to the power of minus 7. So what you get is 8.4. 8.4 times 10 to the power of minus 7 as your answer. Now, what is the unit? What will be the unit? The unit is mole per second, molarity per second. Wahala for who have not been following my series on this video. I wrote molarity per second. You may not know how I got it. It means that you have not been following my videos. Please check those videos. So that is it for this answer. Now we want to get the one of O2. And from this answer, I will let me put plus here. You can see that we got plus. And you can see that NO2 is on the product side. It is increasing. Right now, we got an answer to the plot. That means we are on the right track. Now, let's continue. Now, we want to calculate and get the one of oxygen. This is so easy. If you understand this, you will not even be writing. The reason I'm writing all this thing at the board is because this is a video. I want to explain it as easy as I can. Now, you have the one of this, and they want you to calculate the one of this. Just come to overall reaction. You will pick this, you equate it to this. You make this the subject of the formula, and you get your answer. So from here, look at, I will equate this and this. Why am I equating this and this? Because I already have this. I cannot have two unknown, you cannot solve it. You only need one unknown. So I already have this, I will equate it to this and get my answer. So from here you have minus 1/2 N2O5 all over the T is equals to the O2 all over the T. Now from here you can see that there's not even any coefficient. Therefore, already the O2 all over the T is already subject of the formula. So all I need to do, I'll just insert the thing. This is minus 1/2. Remember, this is disappearing, so it's minus 0.2 minus 7. So, of course, minus times minus will give me plus, so we are on the right track. So all I need to do right now is punch your calculator. Of course, you get 2.1. The answer will be 2.1 times 10 raised to the power minus 7. Let me confuse some people that have not been following my channel. The SI unit now is mole dot minus 1 dot S minus 1. That is the answer. Let me confuse some people. If you have not been following this series, you will now say, this molarity per second, and I'm now here writing mole dot L minus 1 dot S minus 1. Wahala don't do. Follow my channel, the answers to all these things are there. Let's go to the next example, please. Now, this example, we have the equation, this to this. Now, the question number 1 is, how is the rate of ozone related to the rate of oxygen appears in the reaction? That means they just want you to get the overall rate of the reaction. And from here, if you want to get the overall rate of the reaction, we have been doing it. Please pause the video and write the overall rate of the reaction. From here, the rate is now the coefficient first, 1 all over 2, the concentration of ozone all over the T is equal to, I do not include something in this equation I just wrote now. What is it? Pause. What is the answer? I did not include minus. Never you make that mistake. Never you make that mistake. This is minus 1 all over 2 dt because it is disappearing. Of course, the next thing is equals to plus the concentration of oxygen. Of course, we write the coefficient first. 1 all over 3. The concentration of O2 all over dt. This is the answer to part A. So easy. Now, if the rate at which oxygen appears, so the rate of, that means the O2 all over the T is equals to plus 6.0 times 10 raised to the power of minus 5. What is the rate at which ozone O3 disappears? They want you to, you already have the equation. They are giving you this. They want you to get this. So all you need to do is make this the subject of the formula. And you know the way we used to do it. I will first leave the coefficient first and write the concentration of O3 all over the T is equal to, I'll write this like this, 1 all over 3, the O2 all over the T times, I said, when you want to make, so that you not confuse yourself, when you write it like this, and you remember we forget the coefficient. Now, times it, invert the coefficient, and include the sign. So all you need to do here is invert the coefficient, include this, and this is minus 2 all over 1. That's all. You are done. The same thing, if this was plus, invert it, the coefficient, include the sign. Now, all you need to do is now write your answer. 1, this is equal to 1 all over 3. The T the concentration of oxygen are already been given to be what? 6.0 times 10 to the power minus 5. Remember, times minus 2 all over 1. This is so easy. If you just put it like that, you are done. You are done. That's all. If you punch it in your calculator, what you should get is 4.0. 4 minus, of course, minus. Remember, we have minus 4.0 times 10 to the power of minus 5. And of course, mole per second. Let me play with it again. It can also be minus 4.0 times 10 to the power of minus 5 mole dot L minus 1 dot S minus 1, or minus 4.0 times 10 to the power of minus, and I can write it as mole into L dot X. If you have not been watching my channel, you may be confused at this particular moment. Watch the part 1 of chemical kinetics and thank me later. So that is the answer for that thing. And if you can see, our answer contains minus. That means we are very correct, because here at the equation, ozone is at the reactant side. It's at the reactant side. That means that ozone is disappearing, and hence the answer is correct.